You see, the thing about lights, they help you see. And I have a problem. My room doesn't actually have a light that is attached or controlled by this light switch. There's no overhead light. But what I do want to do is allow this light switch to power the two lamps that are on the other side of my room. The problem is this switch controls an outlet, which is on this side of the room, down here. So I need to find a way to wirelessly power these lights behind me using that light switch. So let me show you the plan. On the left side, which we can call our transmitter side, we have an Arduino Nano, which is a small microcontroller, but for our purposes, we will call a computer, that will be plugged into the wall outlet, which our light switch will be powering. This computer will then control and power a transmitter, which will send 433 millihertz frequency that our receiver will be looking for. Now on the right side, we have our receiving side. This side is a little bit more complex because it's where our lights plug into. So starting off on the right, we have our wall outlet, which will plug into our power strip, and our lights will also be connected then to that power strip. Then we have a relay, which is, you can think of, an on or off switch that will be connected to our Arduino Nano, and of course, a receiver, which will be looking for our transmitter signal. So to summarize, once the lights are turned on over here, our transmitter will send a signal, which our receiver will be looking for. And once that is received, our computer will tell the relay to allow power through the power strip to power on our lights. So here is a logical diagram of the receiving side showing all of the components and how things are connected. And on the other side, we have the transmitter with its components and connections. Now for the code, we'll start with the transmitter side. The transmitter side is using pin number 10 to connect to the Arduino. The transmitter is using a common protocol to send the 433 millihertz frequency with a short pulse, and it repeats many times in that pulse so that it works reliably. And then in the loop, it keeps sending the secret code 123456 every 800 milliseconds. This way, it keeps constantly transmitting so that the receiver can pick it up. Now on the receiver side, we have a relay, which is like an on and off switch, which is plugged into pin number 8 on the Arduino. And we first set our relay to off as the default state, and we will also have our receiver start looking for signals. In the loop, our receiver will be constantly looking for that secret code, 123456, from our transmitter. Once it receives the code, it sets our relay to on, which then turns on our lights. At the bottom, the code is looking to see if our receiver hasn't seen a signal in 5 seconds, then it will turn off the light. So now that we've gone over all the boring stuff, let's jump into a time lapse. First, at the bottom of the screen, I'm wiring up the transmitter side, and then I jump to the receiver side. I'm now wiring up the relay, connecting it to the board and making sure it has power. And then I'm connecting up the LED, which will be able to light up, and finally the receiver, which I'm currently wiring here. All right, so now that we've got our code uploaded, and we have our receiving side and transmitter side with our LED here, we're going to simulate turning on the light switch by adding the antenna on the transmitter side so that the signal is strong enough to reach the receiving side. So as soon as I touch this here, you can see our light turns on. And currently the timeout is set to 5 seconds, so at 5 seconds it will then turn off. So now that we've confirmed everything's working with our test LED here, we can now go on to start wiring up our power strip. All right, now on to the power strip. So here we're going to want to cut this wire, which you can see I've already done, right after the switch that's actually on the power strip, so that if we wanted to, we can still have a manual off switch for the entire outlets, but we'll always have it in the on position. And what we'll end up doing is taking these two wires here and attach these and then connect these two ends to our relay. That way, the only way these outlets receive power is when our relay allows power through due to receiving a signal from the transmitter. Unfortunately, my video stopped recording, but I wasn't able to use these connectors due to them being too large to actually fit inside. So what I went ahead and did was use electrical tape to connect these wires. And eventually we'll drill holes into these so that they are able to come out and this can completely close. But for now, we'll be able to use this to test. Now I'm going to go ahead and connect the relay to this side. Okay, now we should be able to do our first test. Okay, so for our test, we're going to take our receiving side, which we have plugged in and powered, connected to our relay, which is now connected to our power strip. What I've done is plug in a Google Home or an Alexa device. And so, once we take our transmitter side, which I have here, we're going to go ahead and plug this in down there, which I'll do now. And now we have our transmitter plugged in. You can see just using a simple phone charging block. But you can see the LED is not lit yet. That's because our light switch is still off. So in theory, as soon as we turn on that light switch, we should transmit a signal from here. Our receiver should pick it up and then power that Alexa. So let's give it a try. I'm going to go ahead and flick the light and we'll watch. That test ended up not working. So I ended up coming over and I wanted to just double check that I wasn't too far away. I'm using a paperclip antenna, which isn't even the best to use, and the receiver side has not had an antenna set up. So I figured I could try just plugging it in right next to the receiver on my computer, powering it there instead of the light switch. And now you can see our Alexa powers on. So we need to find a better solution to the antenna, both on the receiving side and the transmitter side, and we should be. Now that we've gone through our testing, we're going to go ahead and work with the boxes we're going to use to house our electronics. And it's going to take a little bit of drilling and finagling things around, but we're going to play with trying to get everything snug and fit, and then test from there. And here's another time lapse. So here I'm starting with the receiving side. And so I'm cutting some holes and drilling them, making sure to mark where they need to be so the cords can properly exit the enclosure. Then it also took some manual cutting with a retractable knife to create a pocket low enough for the wires to actually fit into so the lid could close. I'm also permanently connecting the relay here to the power strip and securing all the wires and making sure the antenna properly comes through the top. And there we go. The first side is done. Now on to the transmitter side. Mainly I needed just to create a hole on top for the antenna to go through. And boom. Now on to the power strip. For the power strip, I mainly just needed to cut the plastic sides so that the wire could come through the enclosure and properly close. I also used a retractable knife for this as it cut the plastic pretty easily. And boom, the power strip is good to go. All right, so here we have our boxed up transmitter side. And then over here we have our power strip, which is connected to our receiver side. Goes to the relay and then of course to the computer. And you can see our antennas are coming out of our enclosures here. And now we should be good to get these in position and do our test. Okay, so to quickly show the setup, as a reminder, we have our transmitter here, which will be powered by this light. And it is sending the signal right over here, which is going to power on this lamp and then that lamp as well, which has an extension cord running over to our power strip. So we'll go ahead and tuck this guy away in the corner here as far as we can so we don't have any interference from it. Then we will plug this into the wall. You can see our receiver side is already powered, but now we just need to wait on our transmitter. All right, moment of truth. Once we hit this light switch, at least one of the lights should turn on. I realize my second light, with it being a touch lamp, it still manually needs to be turned on, but let's give it a whirl. Boom! And come over here. This now should also be enabled. So I'm sure, as you could tell there, our lights were still flickering, meaning we weren't getting a great connection between our transmitter and transceiver. So what I did was, I just moved the receiver closer to the transmitter from where it originally was over there. So now we're able to walk up, hit our light switch, and bam, we've officially wired it wireless. And in case you were wondering, this is how I held my phone. Goodbye!